Welcome to Acteon Energy, Acteon's podcast where offshore expertise and innovation meets global energy insight. Hosted by a range of voices from across our global teams, we dive into the data, engineering knowledge and operational expertise, driving smarter, safer and more sustainable energy solutions. We act across the full project lifecycle and we're here to unpack the ideas shaping the future of offshore energy. Let's get started.
Hi everyone, this is episode we tackle one of the most critical and costly challenges in offshore wind, installation risk. I work for Acteon in the Menck Marine Foundation business line, and my name is Fabian. I'm joined today by Ben. Hey Ben.
Thanks Fabian. I also work for Acteon, but in the 2H offshore engineering business line. I'm excited to be here today.
Certainly great to have you. So, brief introduction to the topic today. From weather delays and sole surprises to equipment breakdowns and contractual complexities, installing foundations has become a high-stake operation where planning alone is not enough. We'll try to explore how industry leaders are shifting from reactive approaches to proactive strategies by maybe using real-time data to adapt in the field, by maybe structuring contracts that share risk more fairly, and certainly by engineering solutions designed for flexibility and not just forces. So stay tuned, stay on board, whether you are in project management, operations or commercial strategy. I believe this episode offers practical perspectives on how to reduce exposure and maybe gives you a new opportunity to look at the challenge of tomorrow differently. So let's get it started. Looking from my perspective, and I'm working heavily on the installation side, we are seeing risks already in the contractual propositions set forth. Small operators and contractors like ourselves are contributing to mission-critical equipment strategies on the field installations, though exposed by enormous liabilities through the flow-down clauses on the contract. So Ben, I suggest we tackle this through the life cycle of a project, and you are certainly involved in the pre-installation phases, engineering phases early on and much earlier when before we come into play with the installation equipment. What's your view on the risk for those opportunities today, and do you see that changing over time, past decade versus what do you anticipate for the next decade?
Yes, I definitely think so, Fabian. I think the biggest consideration that we're seeing coming into the early stage engineering now is the importance of that installation phase for choosing the right foundations and then flowing through the whole design of those foundations with that installation really in mind and properly understood. A good example there is as we move to larger and larger monopiles, their installation is getting more and more difficult. Monopiles are great where they work, but there may be other locations where jacket solutions are a more expensive foundation, but significantly de-risk the installation program, for example. There are other examples where we have ground conditions that suggest the need for relief drilling or even drilled and grouted piles. And in those cases, we need to assess that risk early, again, in order to design the foundations correctly, but also to specify the installation spreads and even to target the geotechnical campaigns that give us the confidence in the real ground conditions to plan the T&I operation successfully.
Very interesting, Ben, and thanks for those insights. And reflecting upon that, what I've seen on the installation side regularly is developers and contractors coming out with an expected pile diameter installation that is then to be met through the installation tooling that we provide, but exceeding what is practically possible and available in the market today. So is that design phase for the foundations, like the monopiles, is that actually considering an integrated approach through what is available in the landscape of installation tooling versus what is the installation challenges itself? So any insights to that?
It certainly should. And I think in many cases it does, but sometimes it comes in a little bit too late. So the design of the monopile, there may be a bunch of effort done in designing that, and then a realization that there's some installation challenges there with the supply chain and what's available, and then a whole bunch of rework in order to try and bring that diameter back down. But it's not just the installation tooling, like the flange diameter at the top or the diameter at the top of the monopile for driving. It's also, for example, the entire weight of the monopile. If the monopile is getting heavier and heavier and there's a risk of pile run, for example, which we see in certain ground conditions, particularly in the Far East recently, then the weight of that monopile becomes so extreme that if pile run does occur, it's very hard to arrest that pile run. And therefore the monopile can start to sink significantly further into the ground than you intend, and you have to scrap the entire slot. So it's not just about the installation equipment tooling, it's about the whole installation program, which of course includes that equipment, but is broader than that. And that's all the stuff that needs to be assessed really early on in the sequence in order not to go down the wrong path and have to do a whole load of rework in order to recover later.
Absolutely, fully agree with your points that made there. And pile runs are major events that we have seen all the way along through the development and moving into renewables. But because of the sizes of foundations, they become a very dominant event and harmful for infrastructure, people, as well as the installation progression, as a matter of fact, at the end as well.
And I guess we're talking there about pile run, which is a sort of soft soil problem, or at least where you've got multiple different layers of harder soil that you're having to drive through, and then soft soil when you see the run. But we also have concerns around refusal. And we can, of course, continue to increase the size of hammers, and perhaps you'd like to talk about that a little bit in a moment. But then we also start to run into noise constraints in certain regions. So particularly offshore Germany, but in other regions of the world as well, there are quite tight constraints on noise levels. And so we can't continue to necessarily just blindly increase driving energy without a plan to mitigate the noise as well. So I think we can talk about the pile run, but we can also talk about the pile refusal and incorporating that early on.
Again, experience we had shares your view absolutely, and it's a challenge that we certainly try to address with new technology developments and those technology expectations, anticipations that we are requested to provide to the market from the contractors and client side. Interesting, though, is as well that you touch upon the weights of foundations that contribute certainly to those challenges arising. And from our perspective, there's a massive balance that is needed in these ambitions. A light hammer on a very heavy foundation foundation body doesn't work very well. So we do need to increase these to have the energy that we deliver through impact available to actually progress the pile. But that again delivers higher risk for pile runs, as you touch upon, and fully agree with that point made. So do you think, do you see any avenue that we can actually reduce that, or do you see opportunities in the future that allows us to be smarter around that?
I think for monopiles themselves, I think there's limited strategies to make these problems go away. I think the focus needs to be on the early understanding of them and the planning to mitigate them. I mean, I know, for example, that some of the larger hammers can actually operate more quietly because the technology has advanced in recent years. So that there are opportunities there to understand the issues early and plan around them. But actually mitigating those problems for monopiles is more challenging. The other option, of course, is to look at other foundation solutions, though. We're not completely constrained with monopiles. We can look at gravity-based structures. We can look at jacket structures, which bring their own challenges. But they can be a way to get away from some of the monopile installation challenges that we see.
True, for sure. You touch upon the next generation monopiles and the next larger hammers being quieter and contributing to the noise challenge, or maybe addressing the noise challenge in a context that hasn't been done before. Looking at the tooling that we have built over many, many decades and years, predominantly for the oil and gas, though none adapted to renewables, we have reached a point where we first time design bespoke equipment for the offshore environment, and certainly have taken regulatory design implications towards our design approach on the tooling itself. And that allowed us to have massive contributions and positive impacts by almost reducing 80% of the sound energy pressure underwater through structural design considerations taken forward. At the same time, we see great improvements, particularly on the pile run risk mitigation or identification of a pile run developing through data technologies and data integrations. So being smarter about what we do, have greater transparency on the operational phases, has given us an opportunity where we actually installed offshore Taiwan a jacket with 8 piles, and every single pile ran, and then followed by 330 piles for a wind farm where no single pile ran anymore, but we had adapted this digital technology and the insights to the operational performance of the equipment, as well as, of course, the reaction of the pile itself. We're expanding upon that and trying to leverage these insights that we've never had before through real-time data monitoring and giving the awareness across the entire value chain, from the designers that were involved to, of course, the operators and installation contractors and owners of the wind farm. Though at the end, regulatory framework may burden and challenge a new element and level tomorrow. Do you see changes coming in that from a design side for future foundations?
Yes, I do, Fabian. I think some regions are defining specific limits, and I think more and more regions are going to do that, particularly as foundations continue to grow and noise levels grow alongside them. Other regions, though, we're seeing are simply requiring developers to include within their consent applications evidence that they are working to minimize noise. So even if there aren't firm noise limits being applied in some cases, it's still beneficial to that consent application to demonstrate that you are working to minimize noise using some of the techniques that you've touched on there. And that may be operational, or it may be during design. You talked as well there about taking the learnings from piling operations to guide future piling operations and make operational changes. I think you also touched on taking them back to the engineering learning. And I think we've had some real progress in recent years by working closely together between the foundation designers, people like myself, and the installation equipment suppliers, people like Menck, where we can actually take those operational learnings back into the engineering and design of the foundations. But I think there's a lot more that we can do there, particularly in the noise space, where we're actually looking to measure the level of noise that we're producing during a piling operation, how we can adjust that through procedures and equipment optimization, and then feed that back into that design and consenting process to make sure that we're not being overly conservative by taking a purely theoretical approach. So I think there's a lot more we can do to feed back from operations to design in order to de-risk some of this for developers as well.
Great to hear that, Ben, certainly. Taking a step back to the beginning where I mentioned, well, size matters in a way, and that certainly is theme when you think about all these piles growing, the foundations becoming longer, larger and heavier, as well as the nacelle itself becoming massively in size, being positioned at a much higher elevation with greater diameter rotors and blade lengths being installed. All that certainly implies and presumes that we see cost escalation left, right, up and down, and probably making some of the projects unattractive. So while we touch upon all these installation risks on one side, how do you feel about this cost escalation scheme? Does that justify actually the installation that we see opportunity for in terms of the physical land or sea space available, though is it actually economical to move that forward? And implications currently seen with some of the operators where wind farms are being delayed or even cancelled completely because of cost level implications. Do you feel we have anything to give from our side, from the engineering side and tooling side, to actually contribute to a lower LCOE tomorrow?
Yes, I do. I think the limitation sometimes in the design process is that we design for the in-place condition. So we look at the environmental loads, the overturning loads from the turbines, and as you say, they're getting larger and larger, increasing that loading. And we see the inflation in the cost of the steel, of the fabrication of those components. And the focus is on minimizing that. So sticking with monopiles wherever possible, optimizing that to the nearest millimeter in order to reduce that fabrication weight. And that's good. I'm not saying that's a bad idea. But when focusing on that, we often neglect the cost and the risk during the installation phase. And so many of the offshore wind development projects that we see going on suffer in the installation phase from cost overruns. And I think that is what's scaring a lot of developers and causing them to pull the plug. It's not just the increase in the steel weight and the fabrication cost, which is somewhat linear with the turbine size. It's the additional risk during the installation phase. And anything we can do early on to de-risk that installation and plan that installation particularly considering supply chain constraints as well as technology limits, should allow developers to be more confident in their pricing models. And maybe they need to spend a little bit more on fabrication, on the in-place design, to give something that is reliably installable and hence to de-risk the overall project finances.
So do you reckon this requires a different approach then to the overall, rather than the kind of silo approach where individual packages are being contracted and the developer tries to flange them together or bring them together in alignment, versus maybe a more transparent approach in the overall design phase versus realization installation phases?
Yes, I think it can be too easy to optimize. I think that's a generalization of the point I was making that I completely agree with. It's not looking at individual components, whether it be the foundation or installation pieces of equipment. It's looking at the whole system and looking to make that, to de-risk that and reduce the system cost rather than focusing on individual components. To purchase a full installation spread may appear less cost effective, but if it de-risks the installation, then it probably brings value in the full tone of the project.
Yeah,
I think that's what you were getting at.
Absolutely. Yeah. So some of the installations that we are partnering with on today's development see not only a new hammer being introduced, but a lot of installation tooling and even down to the vessel being introduced new to the market. And all these individual contractors on board the vessel certainly come together, work as a team to deliver the next installation, the next wind turbine spinning offshore. Though we do see as well a lot of downtime created through these new technologies, which add to the complexities. Though, in a way, I believe people need to move together and aim for the right outcome of everything. Because at the end, there's massively more at stake than just the installation and us making money. Certainly, on one side, we're doing all of this for a reason. And we're sitting right now in London at 30 degrees, and it's lovely summertime. But the weather has changed clearly. Well, we're certainly not here to fix climate change at all. But there is a root cause for our ambition and certainly contribute to offshore renewables energies. We see a dominant opportunity not only for our business itself, but certainly making a difference in tomorrow's world with what we do. Innovation drives the new technology developments and certainly provides new enablers in the industry that allows us to maybe build the next larger foundation or with the next larger turbine close to those areas where it's actually needed, because that's where offshore wind really becomes very attractive. Producing power close to the people where they actually do live and deneutralize those or neutralize in terms of carbon footprint those areas from previous energy generations.
Yeah, for sure. I think there's a danger with conversations like this that it can sound quite negative. We're talking about all the challenges and all the problems we face, right? But particularly as an engineer, speaking personally, but also speaking about the colleagues that I work with, it's these difficult challenges that excite us, right? We want to be able to install bigger turbines successfully. We want to deliver projects without having as much installation risk, because by doing that, we can be proud to build another wind farm, decarbonise another piece of energy production. So that's where the excitement comes, I think.
So we do enjoy the challenge.
For sure, yeah.
For sure. Hey Ben, it's been great having you today here in London. 30 degrees outside, we enjoy the weather. It's been great to have you guys listening in, the guys and girls out there listening in. It's been certainly a journey coming to this podcast. Thanks for so much. Look forward to the next episode. See you soon.
Thanks for having me, Fabian.
Thanks for listening to Acteon Energy Podcast. To learn more about how we're applying our data, engineering and operational expertise from seabed to surface, visit acteon.com. Don't forget to follow, rate and share. Until next time.